Today we are going to be continuing our matrix series. Today we are going to be talking about a few operations. Sorry, it was about determinants. Extremely sorry about that was a slip of tongue for me. Today we are going to be talking about two important operations on determinants. And what are those operations going to be? They are going to be addition and multiplication. Okay. So let's first talk about addition. Let's say we have two determinants A and B of order 2 by 2. So if you want to add these two determinants, you would only be able to do so if these two determinants at least have one row or one column in common. So what does that mean is that let's say determinant A has elements A, B, C, D. If determinant B has elements like A, B, A, B, E, and F, then we'll be able to add these two because one column is common. The first column in both determinants consists of two elements A and B. Another way it would be possible if let's say the second row was common. Let's say in both the determinants, the second row consisted of C and D. The first row differed. So let's say E and F. This way too, you'll be able to find out what some of these two determinants would be. Another way this might be possible is when a row of two determinants are the same. Let's say the first row is same. In both determinants, first row consists of elements A and C. And the second one differs, so let's call this element C and F. This way too, you'll be able to find out what the sum of these two determinants would look like. Okay, you get the point. But you must say that what would happen if a diagonal is common? In that case, we won't be able to find out what the determinant would be. Let's say we have B here, and in the diagonal we have D. You can say that these two determinants have the same main diagonal, but still we would not be able to find out what the sum of these two would be because that is how this thing works. Okay? So how does addition work? Let's say these two have the common first columns. So in this case, A plus B would give us a 2 by 2 determinant in which the common row, which consists of, in this case, consists of element A and B, would remain the same, and the other columns would add up together. So first column would have the elements A and B, and the second column would have elements C plus E and D plus F. Okay. If the second column was in common, then second column would have stayed the same, and the first two columns, the first column of both determinants would have added up. If the first row was common, it would have stayed the same. If the second row was common, it would have stayed the same. So basically, get the point. Okay. Now, what about 3 by 3 determinants? Let's say A and B both are 3 by 3 determinants. A, B, C, D, E, F, G, H, I. Now, we would only be able to add these two determinants if two rows or two columns are in common. So let's say this determinant has first or second column in common. A, B, C, D, E, F, and the third column differs. So let's say it has elements P, Q, R. Sorry again, I'm going through a fever right now. So in this case as well, the common rows or the common columns would stay the same, and the row or the column that is not common in both these determinants would add up together. So in this case, the sum of A and B would be a 3 by 3 determinant with the elements in first row as A, B, C, D, F, and the elements of third column would add up together. So it would be G plus P, H plus Q, and I plus R. Okay? If the second and third column was common, then that would just those two would have stayed the same. If any two rows were in common, then those two would have stayed the same, and the row that was not in common, that one would have added. That one and both those determinants would have added up. Okay. Now let's talk about multiplication. Multiplication is a bit complex. Let's talk about it again. Let's talk about 2 by 2 determinants first. Now, if you want to find out the product of these two determinants, we have to at first multiply the first elements of both determinants. So it would give us A plus CG. The second element would be A times F plus C times H. The first element of the second second row would be B times E plus D times G. The second element of the second row would be B times F, not BF, because don't get excited, plus D times H. Okay? First element of the first determinants, first rows, first column times the first element of the first determinant, so the second determinant, like this. Okay? Now 3 by 3 determinant would follow the same pattern, but it is gonna look a bit more complicated. So let me show you that as well in a moment. J2, H2 and I2. Okay, so the product of these two matrices would be, so these two determinants would be a 3 by 3 determinant. Here as well, we're going to be following the same pattern. A1 times A2 plus D1 times D2 plus G1 times G2. This will be the first element. Second element would be A1 B2 plus D1 E2 plus G1 H2. The third element would be A1 C2 plus D1 E2 plus G1 H2. Okay. Then the second row would look like B1 A2 plus E1 D2 plus H1 G2. The second element would be B1 B2 plus E1 E2 plus H1 H2. The third element would be B1 C2 plus E1 F2 plus H1 I2. The third row would look like C1 A2 plus F1 D2 plus I1 G2. Then the next element would be C1 B2 plus, sorry, yeah, it would be C1 B2 plus F1 E2 plus I1 H2. And the last element of this entire determinant would be C1 C2 plus F1 F2 plus I1 I2. Okay, these are the general formulas how things would look like. I just want you guys to memorize all this. In the next videos, we'll be talking about some very interesting and important properties of determinants, and those are gonna come in really handy when you're trying to solve MCQs, especially when you're running short of time. Okay, so I think it's time to wrap this session up. See you tomorrow, and if you guys have any doubts regarding anything I've taught you guys today, please do let me know in the comments, and I'll try to answer your doubts. Until then, keep learning.